This is a question of JEE Advanced 2024 paper 2, question number 16. So in this question what they have done is that they have given that there are two particles 1 and 2, they are connected by and they are doing the oscillatory motion, they are doing the SHM, and these are the equation for their displacement. Now there is a third particle which is moving with the velocity of u0, which is equal to a omega divided by 2. It's the particle 2, and then after the collision 1 and 2 acquire the 1 and 2 center of mass acquires a speed of VCM and oscillates with a amplitude b. Then we need to find out the VCM divided by a omega. We know that whenever there is a collision, this force between the particles will be a impulsive force, but if the other side there is a spring, then this force will not be impulsive. This is non-impulsive. If it is non-impulsive, then we can apply the conservation of momentum at the point of collision. At the point of collision means just before the collision and just after the collision, the momentum of the particle 3 and 2 will remain conserved, right? So let us write down P final is equals to P initial. Here I am taking the 3 and 2 as system. Why? Because 3 and 2 particle will collide. So P final, let's assume that the particle 2 is moving with the velocity of v2 and particle 3 is moving with the velocity of v3. Both are moving in the same direction. So m, the mass of the particle 3 is m. All the masses are m. Okay. Plus m is equals to P initial. Now look, in the P initial, we can write down the particle 3's momentum, that is m multiplied by u0, which is a omega divided by 2, and that is in the right direction, that's why positive. But what to do with the particle 2? We need to find out the initial velocity of the particle 2. So for that we have this equation, displacement equation, x2, which is x0 minus d minus a sine omega. We can differentiate it, we will get velocity of the second particle. Velocity of the second particle, this term will become 0, and we are getting minus a omega cos omega t. They have given that this particle is colliding at t0 equals to 0. So if you put this value at 0, then cos 0 will be 1. That's why v2, this is actually the u2 t equals to 0 is minus a omega. Alright, so let us put this value. We have mu1 plus mu2, so plus u2, that is minus a omega. So m will be cancelled out, and we are getting a equation between the v2 and v3. v2 plus v3 is minus a omega divided by. Now second equation, they have given that the collision is a elastic collision, so we can apply the coefficient of restitution, so that is velocity of the separation. So velocity of the separation would be v2 minus v3 divided by velocity of approach is u3 minus u2, that is v2 minus v3, these two values are unknown, divided by u3 is a omega by 2 as given in the question, and u2 is negative. It means this particle was moving in the left direction, so that's why negative becomes positive a omega. So basically we are getting v2 minus v3 a omega divided by 2. This is our equation 1 and equation 2. Alright, if we add both of the equation, we must get the v2. So 2v2, let's add the equation 1 and 2. 2v2, v3 will be cancelled out, is equals to 3a omega minus a omega divided by 2. Basically v2 will be, look here, this is 2a omega divided by 2, and this 2 again in the division, that becomes a omega divided by 2. Alright, we got this velocity. Alright, at this point let us also find out the velocity of the first particle at t equals to 0. At t equals to 0, velocity of the first particle vu1t is just the differentiation of this equation, so this term will be 0, and we are getting a omega cos omega t. Alright, so just after the collision, let us find out the velocity of the center of mass for the particle 1 and the particle 2. So particle 1 and particle 2, particle 1 is moving with a velocity of a omega, and particle 2 is moving with a velocity of a omega divided by 2. So particle 2 is moving with a velocity of a omega divided by 2. Now how to calculate the velocity of center of mass? m1 v1 plus m2 v2 divided by m1 plus m2. Alright, Now the masses are equal, so m, and this will be 2m. So it is simply v1 plus v2 divided by 2. So that is a omega plus a omega divided by 2 divided by 2. So basically that is VCM equals to 3a omega divided by 4. Now we need to find out VCM divided by a omega. So that is 3 by 4, right? That value is 0.75. So this is the answer for this question. All right. So now the next question. Now in the second part of this question, they have given the similar situation where these two particles connected via the spring and they are performing the SHM by the given equations, and the particle 3 is doing the collision with them, but they have changed it a bit. They have changed the time, and finally they are not asking the VCM divided by a omega as the previous question, but they are asking 4b square divided by a square. All right. So now what we will do is that we will find out the velocities just after the collision. Okay, we will find out the condition just before collision and just after the collision, and if we can apply the maximum compression condition, then we can find out the amplitude from there, and then we can find out the 4b square divided by a square, because finally what they are asking is that if 1 and 2 acquires a center of mass speed VCM and oscillates with amplitude b and same angular frequency omega, so we need to find out 4b square divided by a square, where b is the final amplitude and a is the initial amplitude. All right. So what I'm going to do is I will differentiate these values. At the same time, let's first find out the values. x1t is x0 plus d plus a sine omega t, and t is given as pi by 2 omega. Okay, so x1 pi by 2 omega would be x0 plus d, and basically this value is 1, right? So this is simply a. If we calculate for the x2t will be given as x0 plus d minus a sine omega t, and of course omega t is pi by 2, so then this value is at pi by 2 omega. This particle is at the x0 plus d minus a. All right, these are the values. Now look, the particles are at the extreme positions. The extreme position, we know that at the extreme position the velocity of a SHM will be 0, or either you can differentiate and you can find out the velocities. So when it is hitting, actually what is happening is this is the particle 1, this is particle 2 and 1. Here the velocity is 0. Let's call it as u2 is 0, u1 is also 0, and this is the third particle which is coming and hitting with the u0. Okay, so again we know that this spring force is non-impulsive, so we can apply the conservation of momentum just at the point of collision, and we can also apply the equation of restitution. So let's apply. After the collision they are moving with the velocity of the v3 and v2 as we did in the previous. So we can say m v2 plus m v3 is equals to m u0. All right, why? Because this is only having the velocity, this is not having the velocity, that's why that term became 0. Okay, now next, from the coefficient of restitution, this coefficient is 1 is equals to velocity of separation. So I'm going to take the particle 2, so particle 2 minus particle 1 divided by velocity of approach is particle 3 minus particle 2, so that is u0. All right, so here first I can simplify this equation. So v2 plus v3 is u0. This is our equation 1, and v2 minus v3 is equals to u0. So what we are getting from here? It is quite simple that the 2v2 is 2 u0. v2 is u0. Now look, I could have done it directly. I did it in the previous as well. I did the calculation, but these calculations are not even required if you know that case when there are two masses of the same mass, they are colliding, then and there is a elastic collision, then the velocities will be exchanged, as we know. So that's why the velocities will be exchanged. That's why the second particle is getting a velocity of u0 and the third particle will be in the rest. All right. So we got this. So what is happening just after the collision? This is just before. Let me just copy it. This is just after the collision. This got a velocity of u naught, and this is at rest. Still it is at rest, and this is also at rest. Now there is no roll of this one. Remove it. Now what is happening at this position? Tell me. This spring is having its maximum extension. Why? Because these particles were at the extreme position. So what is the elongation in this spring from its main position? It's a. This particle is a in this direction, in the left direction, and this particle is a in the right direction. That's why the total elongation in this spring is 2a. Now what is going to happen at the maximum compression? Okay, I will tell you what will happen. So look, this is the particle, this is the particle, and this is our spring. They will not go anywhere. They will just keep on moving, right? And this is u naught, this is u naught. So at the maximum compression, we know if the particles will acquire the same velocity, then they will have the maximum compression. This condition we also do when we derive the collision. So u naught divided by 2, u naught divided by 2. If this velocity equally divides, then they will have the maximum compression. And at that compression, the amplitude will be something else. Why? Because the collision is now happened already, and because of that there will be change in the amplitude. So let's suppose it has compressed B from mean position, then this will also compress B from the mean position. So basically 2B. Okay. Now in this situation, from the just after collision to the maximum compression, we can apply the conservation of the total mechanical energy, because surface is frictionless. Whatever energy is stored in the spring plus the kinetic energy will be redistributed in the form of the kinetic energy and the spring potential energy. Why I'm doing that? Because I want to find out the B. That's all. Right. Okay. Now what about the spring constant? If you remember, what is the spring constant? The spring constant is m omega square divided by, alright, this is our spring constant. Okay, we do this derivation, this calculation in the SHM. Okay, so this is our spring constant. Alright, so initially the potential energy, total energy is half m u naught square. This is the kinetic energy of this particle. This particle kinetic energy is 0, so that is half m 0 square plus the potential energy half k value is m omega square divided by 2. And what is the total compression? 2a in this position, 2a square, half kx square. Okay, is equals to the kinetic energy. So we have two particles, m u naught square divided by 4. Let me put it like this because the velocity is u naught by 2. This is the condition, half m u naught square divided by 4. And then we have the potential energy of this spring, which is half m omega square divided by 2. Look, this k will not change. K is the spring constant, that won't change. And we have this spring compression 2b square. Alright, so here we are getting, now look, u naught is also given to you. U naught was given as a, it is given here, a omega divided by 2. Let's put all the values. So first let's cancel out the m, something extra. Okay, here we have u naught squared divided by 2. Okay, let me put u naught as a omega by 2. U naught is a omega by 2. So this is now just a calculation, need to do it a bit carefully. So this is a square omega square divided by 4 multiplied by 2, 8. Then we have there, here it is a square omega square, and that value is 4 divided by 4. 4 divided by 4 is just 1. Is equals to u naught is a omega divided by 2. So a square divided by omega square, and this is 4 multiplied by 2 multiplied by 4, so 16, 32. So this is 32. This will be the same kind of term, that's why 2. Okay, and then we have plus 4 b square omega square divided by 4. Okay, all right. So in total what we are getting is this a square omega square. Let's take it out common. Then here it is 1 plus 1 by 8, 1 plus 1 by 8 minus minus this value 1 by 16 is equals to b square omega square, a square omega square 16, and then we have 16 plus 2 minus 1 is equals to b square omega square. Basically omega square is cancelled out, and we are getting the b square divided by a square is 16, 18 minus 1, 17 by 16. Okay, this we are getting. Now what we need to find out is 4b square divided by omega square. So let's take out 4 from here. So we will get 4b square divided by a square is 17 divided by 4. Okay, 17 divided by 4. Let's find out the value. What is the value? 416 25, 4.25. So this is the answer. So here we did use the concept of the collision, right? Then we used the concept of the this SHM, right? And then again the conservation of the energy. Here the conservation of the energy and the condition for the maximum compression. This is how we are going to solve this question. Hope you understood this problem. Thank you very much.